before on the first day we talked about arithmetic sequences. Arithmetic sequences, you added or subtracted the same number each time to get your next term, and you found the common difference. For arithmetic sequences, you don't add or subtract the same number. We are going to multiply the same number each time. Okay? And so a geometric sequence is a sequence whose successive terms have the same ratio. Okay? So this time, we are not going to be finding a common difference. We are going to be wanting to find a common ratio. Okay? And so what this basically means is for arithmetic sequences, we added or subtracted the same number. For this one, guys, we are going to multiply by the same number, and we are going to call it R to get the next term. Alright, guys, so we are going to multiply by that same number R to get the next term. And this says, determine if the sequences are geometric. If so, then we want to give the common ratio. So we need to, now we're not going to be looking at what we add or subtract, we're going to be looking at what we multiply by. Y'all feel okay with that? So let's take a look at this. So in order to get from 5 to 10, what are we multiplying by? 2. Yeah, y'all feel okay with that? 2. Okay? In order to get from 10 to 15, what are we multiplying by? Yikes, are we multiplying by 2 again? We are certainly not multiplying by 2. Now, if you don't know, I heard it, 3/2. Now, if you aren't sure, then guys, what you can always do is you can say, okay, well, 15 divided by 10, all right? And when you do that, you get this lovely 1.5. I'm going to turn it back into a fraction, and we have 3/2, okay? So then we would be multiplying by 3/2. To get from 15 to 20, we would actually be multiplying by, gosh, I think that's what, 4/3? Yikes. Okay, so are we multiplying by the same thing every single time? No, this is not geometric. However, do you recognize what are we doing to get to the next term every time? To get from 5 to 10, what are we doing, y'all? We're adding 5. To get from 10 to 15, what are we doing? Adding 5. To get from 15 to 20, we're also adding 5. So this is not geometric. What kind of sequence is this one, y'all? Yeah, so this is what we just did. This one is an arithmetic sequence, okay? You guys will sometimes be asked, you'll be given a set of numbers, and you have to determine, is it arithmetic, is it geometric, or is it neither? In this case, it's arithmetic, okay? But it's not geometric, which is what we were actually looking for. And so the answer to the question is no, because it's not geometric. Okay, now let's take a look at B here. What are we multiplying to get from -6 to 12? Ooh, I like it. -2. So we're multiplying by -2. Because -6 times -2 gives you a +12. Okay? What are we multiplying by to get from +12 to -24? I'm sorry? -2 again. Exactly. So we're multiplying by -2 again. And then to get from -24 to +48, we are also multiplying by -2. So guys, is this one a geometric sequence? Yes, it is. Or it is a geometric sequence because you're multiplying by -2 every time. Okay? And guys, our common ratio is -2. Now, one thing that I want you guys to notice is when your ratio is a negative number, then your terms will bounce back and forth between positive and negative. Because every time you multiply by a negative, it's going to change that sign. Y'all feel good about that? So sometimes, guys, your ratio can be a negative number. Okay? I will, in a real world situation, which we'll get to next class, your ratio will never be negative. But in a purely mathematical sense, then yes, your ratio can be negative. Okay? So in terms of sequences, your ratio can be negative. Let's look at C. All right, guys, what are we multiplying by to get from 5 to 1? Ooh, thank you, Will. We're going to be multiplying by 1/5. Okay? Now, Will, what are we going to multiply by to get from 1 to 1/5? 1/5 again. And then to get from 1/5 to 1/25, we multiply by 1/5 again. Now, guys, let's say that's not your strength. Well, once again, you can do the second term divided by the first term, turn that into a lovely fraction, and you get that 1/5 as your ratio. And that works for whatever you're going to do. If you did 1/5 divided by 1, that would still be 1/5. If we did 1/25, I guess I would need to put it in fractions, divided by 1/5, that would still give me 1/5. Okay, so every single time we're getting that constant ratio of 1/5. Now, if you put it in your calculator as a beautiful fraction, then it comes out great. So this one is a geometric sequence, and our ratio is 1/5. Do y'all feel good about that? Okay, so now, guys, I'm going to introduce y'all to two different types of formulas here. The recursive formula and the explicit formula. So because we've already done arithmetic sequences, this will feel a little bit easier today. Okay? Now, because you're already going to be familiar with some of the term lingo. Okay? So we have a sub n. If you have a highlighter, now's a great time to get it out. A sub n equals a sub n minus 1 times your r there. So, guys, our recursive formula for our arithmetic sequence, we added to the previous term. Now, for our geometric sequence, we are multiplying by the previous term. Do you guys feel okay with that? We're multiplying by the previous term. So in this case, guys, remember, in order for recursive to work, you must, there we go. You must know the previous term. Alright? Of course, you can't even see everything I'm writing. You must know the previous term. Alright, guys? And in here, this is very, very similar to the same lingo. A sub n is your nth term, right? A sub n minus 1 is the previous term. But this time, r is that common ratio. Does that make sense? We are going to be multiplying by the previous term instead of adding or subtracting. Okay? So we are going to be multiplying the ratio by the previous term. Okay? Because that's literally what the formula suggests. You multiply the ratio by the previous term, that a sub n minus 1. So, guys, I'm not going to write out a bunch of extra stuff this time. I want us to get a little bit more familiar with this here, okay? So in this particular instance, guys, when you're looking at this formula right here, or this rule that they give us, what is my ratio? What are we multiplying by? What do you guys see? 3. So the ratio is going to be 3. Are you guys comfortable with that? Okay. My ratio is 3. Alright? And if we know that my first term is a sub 5 is 2, we know that. That's given to us. And it says find the next 4 terms. Well, guys, we want to find a sub 6, a sub 7, a sub 8, and a sub 9. Sorry, I got a little tiny there. Okay, I started running out of room. Well, guys, what are we going to do each time? Multiply by 3. So 2 times 3 is 6. There we go. So my sixth term is 6. Okay? And then 6 times 3 is 18. Okay? Then we do here, 18 times 3 is going to be, what is that, 54? Of course, I forgot to put times 3. And then 54 times 3 gives us what? 162. Today, there will be very, very, very little shame in you getting out your calculators, okay? So my next 4 terms, we had our a sub 6 equals 6, a sub 7 equals 18, a sub 8 equals 54, and your a sub 9 equals 162. Alright guys, so I guess I didn't really need to write it out twice, but I did. Okay guys, so every single time we're just multiplying by 3 to get the next term. Okay? Do you guys feel okay with this? So you are multiplying by 3 to get the next term. Okay? So guys, honestly, recursive rules are not crazy complicated if you know how to read them correctly. Okay? Now guys, sometimes your recursive rules can look like this, a sub n parentheses 3. A lot of times you could also see this particular rule written like this, a sub n equals 3 times a sub n minus 1. You might see it like that, right? Where the 3 is in the front. It still just means that you multiply the previous term times 3. You can see it both ways, where sometimes it's in front of the a sub n minus 1, sometimes it's after the a sub n minus 1. You guys okay with that? Okay. Now up next, guys, we are going to be talking about the explicit rule to a geometric sequence, or an explicit formula. Okay? So guys, I think the explicit formula for geometric is infinitely easier than this explicit rule for arithmetic, because you don't really have to simplify it. It's already going to be simplified for you. Okay? And it's going to follow the same exact, we're plugging in almost exactly all the same stuff, but instead of a common difference, we now have a common ratio. So guys, what this formula means is a sub n is equal to a sub 1 times r, the ratio, to the n minus 1 power. So now we're dealing with exponents, okay? And in this case, a sub n is the nth term of the sequence, okay? That n becomes important, right? It's that nth term. And n is your term number, okay? N is your term number. A sub 1 is still the first term of your sequence, just like it was with, in an arithmetic sequence, okay? Still your first term. R is the common ratio between the terms, okay? What you're multiplying by each time. And one thing I want you guys to notice is, guys, in geometric sequences, your numbers get very, very, very big very quickly. Y'all notice they're growing, it's actually growing at an exponential rate because it's growing very, very quickly. If we continued to multiply by 3, it would not take us very long to get very large numbers, right? Because as we continue to multiply, we would get very big numbers very quickly. Okay? So guys, it grows exponentially, and you'll see, guys, for the first time we're dealing with equations that have unknown variables in our exponents, okay? So this explicit rule for the geometric sequence is an example of an exponential function. Alright, guys? So this is our explicit formula. A sub n equals a sub 1, parentheses r, n minus 1. Now, it says, given this following explicit rule, find the first 4 terms in the sequence. So guys, if they give you a rule like a sub n equals 6, parentheses, 5 to the n minus 1, and you want to know the first 4 terms, well guys, we can do this just like we did on the last one, or on our arithmetic sequences, where guys, we replace the n with 1, 2, 3, and 4, because we want to find the first 4 terms. If they ask me what is the 10th term, then I would replace n with 10, okay? But it asks for the first 4 terms, so I'm going to replace it with 1, 2, 3, and 4. So when we do this, we're going to type this in, and it's going to be, or we're going to write it out, y equals, or a sub 1 is equal to 6, parentheses 5, to the n minus 1. Well, in this case, for my first term, my n is just equal to 1. So that's just going to be 1 minus 1. Do y'all feel comfortable with that? Okay. And guys, how many of you guys have had practice typing exponents into your calculator? This is where it's gonna come in really good handy. So check this out. We're gonna do 6 parentheses 5. I'm literally gonna type it just like I did before. And guys, do y'all see this little 6 parentheses 5? I'm going to type it just like I see it. And then guys, right here, do you see that little caret top right there? You see that little caret? It pushes it up. I call it a caret top because it pushes it up. It's kind of like it's going like, it's like pushing something up. So when you push that, it pops it up in the exponent, and you can actually write stuff in the exponent there. So I would type in 1 minus 1. You guys, you could also simplify it and just type 0, right? But when you do that, you get 6. So my answer here for a sub 1 is equal to 6. Are you guys comfortable with that? We're going to do this for each one successively here. So we have 6 parentheses 5, because that's my formula, to the n minus 1 power. Well, now my n is 2, so that's going to be 2 minus 1. And that's going to be equal to, so now you go back to your little calculator here, 6 parentheses 5 to the 2 minus 1 power. Okay? Now, guys, if you can do 2 minus 1 in your head and you just say 6 to the 5 to the 1 power, you can still do it that way, okay? Like, you can simplify the 2 minus 1 in your head. You also don't have to. So this would be 30. Okay? And then we're going to do 6 to the 5th, 6 times 5 to the 3 minus 1 power. So we'd go here, and we'd say 6 parentheses 5 to the 3 minus 1 power, or to the 2nd power. And our answer here is going to be 150. And last, but certainly not least, 6 parentheses 5 times 4 are raised up to the 4 minus 1 power. And when we do this, we type this guy in, and we would say 6 parentheses 5 raised up to the 4 minus 1 power. And we get 750. So guys, what you will notice is these are the first 4 terms of my sequence. Okay, y'all feel good about that? These are the first 4 terms of my sequence. Okay, now what are we doing each time to get the next term? Did you guys track it? Okay, Andrea, exactly. We are multiplying by 5. Are y'all comfortable with that? Y'all are multiplying by 5. Well, guys, what I want you guys to recognize is based on the explicit formula up here, does this actually match, guys? What is my a sub 1 term? Just looking at the formula. What should my first term be? 6. Is that what we got for our first term? Yes. okay? And then looking at our formula, what is the ratio here? 5. So we were multiplying by 5 each time. So guys, could you identify the first term and the ratio just from the formula? Yes. So then if you just wanted to sit there and say, okay, 6 times 5, and turn it into a recursive formula, you could. You could say 6 times 5 is 30, 30 times 5 is 150, 50 times 5 is 750. So you guys can do this two ways. You can plug it in to the explicit formula, or you can identify your first term and your ratio from the formula and just do it recursively. Does that make sense, guys? It's whichever way it's more comfortable for you. Also, something that's kind of cool that you can do is you can also type this 6 parentheses 5 raised up to the, instead of n minus 1, I'm going to say x minus 1. You can actually type it into your calculator, and so the original formula here, and check your table values. And guys, check this out. Ooh, it gets real big real fast. But guys, look. Your first term is 6. My second term is 30. My third one is 150. My fourth one is 750. If we kept going, it would get big very, very quickly. It would raise exponentially. And actually, when you look at it, it goes up like super fast. This is called an exponential function, which we'll look at on Monday. But I wanted to show you guys that. So every time we're just multiplying by 5, and you can identify that from the first term and the common ratio. Y'all feel good about that? Okay. So up next, guys, on this next page, we just have 3 examples that I want to do with you. And guys, because this is so important, we needed to write it twice. It's also up here on the board. You guys can highlight that explicit rule, and you will use this explicit rule to write your term values, okay? So for this explicit rule, it's the same things. Your a sub n is the value of the nth term. Your n is your term number. Your a sub 1 is the first term of the sequence. And r is that common ratio. The only thing that is different than the arithmetic one is the common ratio instead of the common difference. And then obviously the formula itself is different, okay? So what we want to do is, in order to write our rule, we need to identify the first term and we need to identify the common ratio. So what is my first term in 3a here? What's my first term, y'all? Just 2, okay? And the common ratio is the number we multiply by to get the next term. So what are we multiplying by? Oh, we're also multiplying by 2. And it's just a positive 2, isn't it? Yeah, we're just multiplying by positive 2 every time here. So when we multiply by that 2, so this is a little bit unique because both our first term and our ratio are both 2. So if we're going to write our formula here, we would say a sub n is equal to my a sub 1, which is 2, times my ratio raised up to the n minus 1 power. And what is beautiful, guys, is we don't have to simplify this. This right here is your rule for your geometric sequence. Isn't that wonderful? That's the rule right there. Alright, guys? So then, when it says find the 8th term, what are we going to do? Find the 8th term in the sequence. What value does that represent? Is it an A? Is it an R? Is it an N? What is it equal to? It's equal to our N. Our N becomes 8. So guys, this begins to look like A sub 8. My 8th term is equal to 2, because that's my my first value, times 2, because that is my ratio, raised up to the 8 minus 1 power. Alright, guys? So then next, you can just plug that directly into your calculator. You could say 2 parentheses 2 raised up to the 8 minus 1, and we would get 256. Okay? So my a sub 8 is equal to 256. However, some of you guys would rather type in 2 parentheses 2 raised to the 7th power, because you know, guys, I expect you guys to be able to know 8 minus 1 is 7. So guys, if you would rather do that, 2 parentheses 2 raised up to the 7th power, it still gives you 256. So you don't have to subtract it, but if you would rather subtract it, you can. Y'all feel good about that? Okay. Let's take a look at this next example. I'm going to go through these pretty quickly, and then we'll just be done. Okay? Find the rule for the geometric sequence. So the first thing we always want to do is identify what is our a sub 1. What is my first term? Negative 22. That's not a trick question. It really is that simple. Okay? The second part here, this is the difficult part, finding that common ratio. Okay? So what am I multiplying by to get from negative 22 to negative 11? Oh, 1/2. Okay? So guys, you can also remember, you can do that by saying, okay, negative 11 divided by negative 22 gives you that 1/2. Gives you that, when you turn it back into a fraction, it gives you that 1/2. Guys, you also could put 0.5. That's totally acceptable. You did it as a clean decimal, that's totally fine. Okay? But I like fractions, so I'm going to stick with the 1/2, okay? So then if I was going to write my value here, I'd say, okay, a sub n is equal to my a sub 1, which is negative 22, parentheses 1/2, raised up to the n minus 1 power. Okay, guys? And that right there is our written geometric rule. Now, what do I do if I want to find my 7th term? I put my n equal to 7. So I would say, okay, well, a sub 7 is equal to negative 22, parentheses 1/2, and then I'm going to raise that up to the 7 minus 1. Okay? You could also write it as negative 22 times 1/2 raised to the 6th power. You could do it either way when you type it in. Now guys, when you do this in your calculator, I do recommend using the fraction form just because I think it makes it look a little bit cleaner. So if we went negative 22 parentheses, if you do choose to do it as a fraction, I would recommend doing it as in fraction form here. And then you raise it up to the 7 minus 1 power, and you get negative 11 over 32. So my a sub 7 is equal to negative 11 over 32. Now, if you had done the same exact thing, and instead of 7 minus 1, you just did 6, you would still get negative 11 over 32. And guys, if you did the same thing, and instead of 1/2, you did 0.5, raised up to the 6th power, you would get this really ugly looking decimal, but I would try to turn it back into a fraction, and when I do, it's still negative 11 over 32. So guys, you can do it as a decimal, but if you do it as a decimal, always please try to turn it back into a fraction. Does that make sense? And don't use the decimals if it's not a clean decimal. It's like 1/3, don't do it. Leave it as a fraction because that's more accurate. Okay? If it's like 0.25 or 0.5 or 0.2, you can do it as a decimal, but just always turn it back into that fraction. Y'all feel good about that? Adrian, did you have a question? How do I turn into a fraction? You hit this little, okay, so I'll go back. Okay, so when it's this little decimal right here, I go to math. You see that little math button? It's right under alpha. And then do you see how it says arrow frac? So that means I'm going to turn it into a fraction. So I want my answer turned into a fraction, and it turns it into a negative 11 over 13. And if it's an irrational number that will not turn into a fraction, it'll just still spit out a long decimal. So if it doesn't work, it'll just stay a decimal. Okay? So good question, good question. All right, last one here, and then we're going to be all done. Let's find the rule for this geometric sequence below. Okay, guys, so my rule, remember, these guys on top are the term numbers, all right? Everything up here are the term numbers. So this is term number 1 is -2. So these guys down here are your term values, all right? So guys, my terms are -2, 10, -50, and 250. Do y'all feel good about that? So those are my actual terms. So guys, looking at my terms, what is my first term here? So a sub 1 is equal to -2. Excellent. Okay? What is my ratio? What is my common ratio? What am I multiplying by? Ooh, -5. So this is one of the first times we've had a negative. So we're going to multiply by -5. So you notice it's flip-flopping back and forth, right? It's positive, negative, positive, negative, positive. Okay? So that's going to be a -5. All right? So my R right here is going to be a -5. So if we want to write our rule for the sequence, then how we would write this is I'm going to go ahead and actually just write it over here. My a sub n is equal to, let's see here. Remember, we start with our a sub 1, so that's going to be -2 times -5, because that's our ratio, raised to the n minus 1 power. So if we want to find our 9th term, okay guys, then my n is now going to be equal to 9. Are you guys comfortable with that? So we are going to say, okay, well, a sub 9. So this right here is my rule, okay? So technically this is kind of the answer to the first part there. Okay, that's my rule. But a sub 9 is equal to -2 times -5 raised to the 9 minus 1 power. Okay? You also could write this as -2 times -5 raised up to the 8th power. Whichever way you're comfortable doing that. Okay? So we go here and we say -2 times -5 raised up to the, I'm going to say 9 minus 1. Oh. Did I do something wrong? Okay. -2 times -5 raised up to the 8th power. Is that right? Okay, are you guys good with that? So this right here would be raised up to the 8th power. So that is going to be equal to -781,250. So my a sub 9 is equal to -781,000 times 250. And so you guys see that this grows very, very quickly. Do y'all see that? Okay? So it got real big, or the numbers got really, really big, really, really fast. All right, guys? How do y'all feel about geometric? I think geometric is actually a little bit easier than arithmetic, but you just have to know what we're doing here.